Yes, the National Electrical Code (NEC) requires that grounding rods and panels be bonded together. This requirement exists to ensure a low impedance path to ground for electrical faults. The purpose of this low impedance path is to facilitate the quick operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. Without proper bonding, fault current may not be high enough to trip the breaker, creating a potentially dangerous situation. Secondly, yes, the grounding bus and neutral bus must be separated in a subpanel. The neutral bus in a subpanel is connected to the ground and neutral conductor of the feeder supplying the subpanel. The grounding bus, on the other hand, is connected to the grounding electrode system. Separating these buses prevents neutral current from flowing on the grounding conductors, which can cause nuisance tripping of ground fault circuit interrupters (GFCIs) and create stray voltages on metal parts. No, a subpanel cannot be treated the same as a subpanel noted in section 250.32 of the NEC. Subpanels addressed in 250.32 are allowed to be grounded through a grounding rod or a pulled bonding wire because they are supplied by a feeder that includes an equipment grounding conductor. However, when a subpanel is supplied by a 3-wire feeder without an equipment grounding conductor, it must be grounded with a grounding rod. The inspector is correct. To meet code requirements, a bonding wire should be installed between the grounding rods and the two panels. This measure ensures a proper grounding system, protecting the house's occupants from electrical hazards. Let's delve deeper into the requirements and rationale behind grounding and bonding in electrical systems. The NEC provides specific guidelines to create a safe and effective electrical system. Proper grounding and bonding are essential for minimizing electrical shock hazards and preventing damage to equipment. Firstly, let's consider the grounding electrode system. This system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes that are in direct contact with the earth for at least 10 feet. These electrodes are connected together to form a grounding electrode system. The grounding electrode system's purpose is to provide a reference point for the electrical system and to dissipate fault current into the earth. Secondly, the equipment grounding conductor (EG) is a critical component. The EGC is a conductive path that connects the non-current carrying metal parts of electrical equipment, such as enclosures, conduit, and motor frames, back to the source of power, typically the service equipment. This conductor provides a low impedance path for fault current flow, facilitating the operation of overcurrent protective devices. The EGC can be a wire, metal conduit, or other approved raceway. In the case of a fault where a live conductor comes into contact with the metal enclosure of equipment, the EGC provides a path for the fault current to return to the source. This high fault current causes the overcurrent protective device to trip, quickly disconnecting the circuit and preventing a dangerous shock hazard. Thirdly, bonding is the process of connecting together all non-current carrying metal parts of an electrical system to create a continuous electrical path. This includes metal conduits, enclosures, equipment frames, and other metal components. Bonding ensures that all these metal parts are at the same electrical potential. This equipotential bonding minimizes the risk of electric shock by reducing the voltage difference between different metal parts that a person might come into contact with. In the context of subpanels, the separation of the neutral and grounding buses is crucial. The neutral conductor carries the normal unbalanced current in the circuit. The grounding conductor is intended to carry fault current only. If the neutral and grounding buses are connected in a subpanel, neutral current can flow on the grounding conductors. This can lead to several problems, including nuisance tripping of GFCIs, electromagnetic interference, and stray voltages on metal parts. The NEC requires that the neutral and grounding buses be kept separate in subpanels, with the grounding bus connected to the equipment grounding conductor and the grounding electrode system. When a subpanel is fed from a main panel, it is essential to install an equipment grounding conductor (EG) along with the circuit conductors. This EGC provides the low impedance path for fault current back to the main panel, facilitating the operation of overcurrent protective devices. In situations where a subpanel is supplied by a 3-wire feeder without an equipment grounding conductor, the NEC requires the use of a grounding electrode at the subpanel location. This typically involves installing a ground rod and connecting it to the subpanel's grounding bus. However, it is crucial to bond the grounding electrode at the subpanel back to the main service grounding electrode system. This bonding ensures that all grounding electrodes are at the same potential, minimizing voltage differences and providing a more effective ground fault path. The bonding conductor should be sized according to the NEC requirements based on the size of the service entrance conductors. Grounding and bonding are not only about safety but also about ensuring the proper operation of electrical equipment. A properly grounded and bonded system helps to reduce electrical noise and interference, improving the reliability and performance of sensitive electronic devices. In addition, proper grounding and bonding can help to protect equipment from voltage surges and other electrical disturbances. The NEC provides specific requirements for the installation and maintenance of grounding and bonding systems. These requirements are designed to ensure that electrical systems are safe and reliable. It is essential to consult the NEC and other relevant standards when designing, installing, or maintaining electrical systems. Regular inspections and testing of grounding and bonding systems are also crucial to ensure their continued effectiveness. Now let's consider the specific situation with the house's electrical system. The original service entrance had a 3-wire cable running to the main panel, grounded with a rod. When an addition was added, a new main panel was installed at the addition's location, also grounded with a rod. The original panel became a subpanel fed from the new panel with a 3-wire connection. In this scenario, it is imperative to ensure that the grounding systems of both panels are properly bonded together. The NEC requires that all grounding electrodes be bonded together to form a unified grounding electrode system. This bonding minimizes voltage differences between the grounding electrodes and provides a more effective path for fault current to flow. To meet code requirements, a bonding wire must be installed between the grounding rods at the two panels. This bonding wire should be sized according to the NEC requirements based on the size of the service entrance conductors. Additionally, the neutral and grounding buses in the subpanel must be separated. The neutral bus should be isolated from the subpanel enclosure, and the grounding bus should be connected to the grounding electrode and the equipment grounding conductors. The equipment grounding conductors should be run with the circuit conductors from the main panel to the subpanel. In this case, since the subpanel is fed by a 3-wire feeder without an equipment grounding conductor, the grounding electrode at the subpanel is essential. However, it is equally important to bond this grounding electrode back to the main service grounding electrode system with a properly sized bonding wire. By implementing these measures, the electrical system will meet code requirements, providing a safe and reliable electrical supply for the house. It is recommended to consult with a qualified electrician to ensure that all work is performed in accordance with the NEC and local electrical codes. Proper grounding and bonding are not just about meeting code requirements, they are about protecting people and property from electrical hazards. A well-designed and properly installed grounding system is a critical component of a safe electrical system. Let's elaborate further on the NEC sections relevant to this situation. NEC section 250.50 covers the grounding electrode system. This section requires that all grounding electrodes be bonded together to form a grounding electrode system. The purpose of this requirement is to create a low impedance path for fault current to flow back to the source. This helps to ensure that overcurrent protective devices operate quickly and effectively, minimizing the risk of electrical shock and fire. NEC section 250.52 specifies the types of grounding electrodes that are permitted. These include ground rods, ground plates, metal water pipes, and concrete encased electrodes. The grounding electrode must be installed in accordance with the NEC requirements. For example, ground rods must be driven at least 8 feet into the ground and be separated by at least 6 feet. NEC section 250.130 addresses equipment grounding. This section requires that all non-current carrying metal parts of electrical equipment be grounded. The purpose of this requirement is to provide a low impedance path for fault current to flow back to the source. This helps to prevent electrical shock hazards by ensuring that metal parts do not become energized during a fault. NEC Section 250.142 covers the use of the grounded circuit conductor for grounding equipment. This section restricts the use of the grounded circuit conductor for grounding equipment on the load side of the service disconnecting means. This is to prevent neutral current from flowing on the grounding conductors, which can cause nuisance tripping of GFCIs and create stray voltages on metal parts. NEC Section 250.32 specifically addresses grounding requirements for outbuildings and separate structures. This section allows for the use of a grounding electrode at the separate structure, provided that the grounding electrode is bonded back to the main service grounding electrode system. This bonding is essential to ensure that all grounding electrodes are the same potential. In summary, proper grounding and bonding are critical for ensuring the safety and reliability of electrical systems. The NEC provides specific requirements for grounding and bonding that must be followed. It is essential to consult the NEC and other relevant standards when designing, installing, or maintaining electrical systems. Regular inspections and testing of grounding and bonding systems are also crucial to ensure their continued effectiveness. In the context of the house's electrical system, it is essential to bond the grounding rods at the two panels together with a properly sized bonding wire. The neutral and grounding buses in the subpanel must be separated, and the equipment grounding conductor must be run with the circuit conductors from the main panel to the subpanel. By implementing these measures, the electrical system will meet code requirements and provide a safe and reliable electrical supply for the house. Let us consider the specific wire sizes required for grounding and bonding. The size of the grounding electrode conductor, which connects the grounding electrode to the equipment grounding bus, is determined by NEC Table 250.66. This table specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The bonding jumper, which connects the grounding electrode to a separate structure to the main service grounding electrode system, must be sized according to NEC Table 250.102. This table specifies the minimum size of the bonding jumper based on the size of the largest ungrounded conductor supplying the separate structure. The equipment grounding conductor, which connects the non-current carrying metal parts of electrical equipment to the equipment grounding bus, must be sized according to NEC Table 250.122. This table specifies the minimum size of the equipment grounding conductor based on the rating of the overcurrent protective device protecting the circuit. It is important to note that these are minimum sizes, and larger conductors may be required in certain situations, such as when long distances are involved or when the impedance of the grounding path is high. In addition to wire size, the type of conductor used for grounding and bonding is also important. The NEC specifies that grounding and bonding conductors must be made of copper or other corrosion-resistant material. The conductors must also be properly identified as grounding conductors, typically by being bare or green in color. The installation of grounding and bonding conductors must be done carefully to ensure that they are properly connected and protected from damage. The conductors must be run in a manner that minimizes the risk of physical damage and corrosion. Connections must be made using approved methods, such as listed connectors or compression fittings. Grounding and bonding are not a one-time task, it needs to be checked routinely. It is essential to periodically inspect and test grounding and bonding systems to ensure that they are functioning properly. This includes checking the connections for tightness and corrosion, as well as testing the impedance of the grounding path. Any problems that are identified should be corrected promptly to maintain the safety and reliability of the electrical system. It is always recommended to consult with a qualified electrician when working on electrical systems. Electrical work can be dangerous, and it is important to have the knowledge and experience to do the job safely and correctly. A qualified electrician can ensure that the grounding and bonding system is properly designed, installed, and maintained. Grounding and bonding are fundamental aspects of electrical safety. By understanding the principles of grounding and bonding and following the requirements of the NEC, it is possible to create safe and reliable electrical systems. This information is for educational purposes only. Consult with a qualified electrician for specific advice related to your situation. Always follow all applicable electrical codes and safety regulations. Understanding grounding electrode conductor sizing, bonding jumper sizing, and equipment grounding conductor sizing is critical for ensuring a safe and code-compliant electrical installation. Always refer to the latest edition of the National Electrical Code, NEC, and consult with a qualified electrician for specific guidance on your project. The correct installation and maintenance of grounding and bonding systems are essential for protecting people and property from electrical hazards. Let's further consider the impact of improper grounding and bonding. Inadequate grounding and bonding can have serious consequences, including increased risk of electric shock, fire, and equipment damage. When a fault occurs in an improperly grounded system, the fault current may not have a clear path back to the source. This can cause metal parts of equipment to become energized, creating a shock hazard. If a person comes into contact with an energized metal part, they could receive a severe or even fatal electric shock. Improper grounding can also increase the risk of fire. When fault current flows through an unintended path, it can generate heat. If the heat is sufficient, it can ignite nearby combustible materials, leading to a fire. In addition, improper grounding can damage sensitive electronic equipment. Voltage surges and other electrical disturbances can damage or destroy electronic components if they are not properly grounded. The cost of repairing or replacing damaged equipment can be significant. For these reasons, it is essential to ensure that electrical systems are properly grounded and bonded. A well-designed and properly installed grounding system is a critical component of a safe and reliable electrical system. Ignoring or neglecting grounding and bonding can have serious consequences. It is always best to err on the side of caution and ensure that electrical systems are properly grounded and bonded. Consulting with a qualified electrician is the best way to ensure that electrical work is done safely and correctly. A qualified electrician can assess the specific needs of a building or facility and design a grounding system that meets those needs. They can also install and maintain the grounding system to ensure that it continues to function properly. In addition to following the NEC requirements, it is also important to consider the specific characteristics of the soil when installing grounding electrodes. The soil resistivity can affect the effectiveness of the grounding electrode. In areas with high soil resistivity, it may be necessary to install multiple grounding electrodes or use other methods to improve the grounding effectiveness. Regular testing of the grounding system is also important to ensure that it is functioning properly. The testing should be performed by a qualified electrician using appropriate test equipment. The results of the testing should be documented and kept on file. Grounding and bonding are essential for protecting people and property from electrical hazards. By understanding the principles of grounding and bonding and following the requirements of the NEC, it is possible to create safe and reliable electrical systems. Remember to always consult with a qualified electrician for specific advice related to your situation. The inspector is correct to request the bonding wire is installed between the grounding rods and the panels. This ensures safety.